this is Nidhi Ghetia. Today we discuss about the Cannizaro reaction. So we get first we learn about the introduction of the Cannizaro reaction. So Cannizaro reaction is discovered by the Stanislaw Cannizaro. Stanislaw Cannizaro discovered the Cannizaro reaction. He is the scientist of the Cannizaro reaction. It is generally occurs in an aldehyde that not having a alpha hydrogen. This is the self-oxidation and self-reduction reaction, so also known as a redox reaction. In this reaction, two molecules of the aldehyde are reacted to produce a primary alcohol and carboxylic acid salt. The reaction occurs in the presence of the aqueous or alcoholic NaOH or KOH. Reaction occurs in the presence of alcoholic NaOH either KOH. Two aldehyde molecules plus NaOH either KOH, and then we get the one carboxylic acid salt and then one primary alcohol molecule. In this reaction, the oxidation product is the salt of the carboxylic acid and reduction product is a alcohol. Oxidation process product is a carboxylic acid salt and then reduction process product is a alcohol. So it is also known as a redox reaction. Reaction of the carboxylic reaction of the formaldehyde. We take two molecules, 2 moles of the formaldehyde, reaction with the NaOH, and then we get the one primary alcohol and sodium salt of the carboxylic acid. As well as aromatic reaction is a benzaldehyde and then reacted with the NaOH, and we get the benzyl alcohol and sodium benzoate. Sodium benzoate is an aromatic salt of the carboxylic acid. Then we learn about the mechanism. So in this mechanism, which type of reaction follows? Like nucleophilic substitution reaction. This reaction involves the nucleophilic acyl substitution on aldehyde while leaving groups attack another aldehyde in a next step. First, step number 1. This mechanism follows in a 3 step. First, step number 1. Hydroxide group attack on carbonyl group to form a anion. First, OH hydroxide group means OH group directly attached to attack on a carbonyl group. Carbonyl group, what is carbonyl group? Carbonyl group is any carbon compound having a double bond O, that's called carbonyl compound. OH group directly attached with a carbonyl compound, and we get the one derivative of the carboxylic acid. Not that proper carboxylic acid, but it is a derivative of the carboxylic acid. This is reversible or irreversible mechanism. Step number 1 is a reversible or irreversible reaction. Then step number 2, one derivative of the carboxylic acid and then one molecule is a aldehyde. Aldehyde and carboxylic acid both are reacted. Derivative of carboxylic acid and aldehyde both are reacted, and then one H is transferred to carbonyl atom, and then we get the one carboxylic acid and one derivative of the alcohol. Not is the alcohol but derivative of the alcohol. Addition and removal of the hydride ion take place to form salt of the carboxylic acid and alcohol. So C6H5CH2O minus. O minus is a anion, then H plus attached with a O minus, and we get the benzyl alcohol. So aromatic primary alcohol. We get the benzyl alcohol. So 3-step mechanism is followed, and then we learn about the cross Cannizaro reaction. Any compound Cannizaro reaction take place between two same molecules, but cross Cannizaro reaction is take place between two different aldehyde having a no alpha hydrogen in structure. That's called cross Cannizaro reaction. That is 4 products are formed. First benzaldehyde we take, then reacted with the formaldehyde. First benzaldehyde and formaldehyde that is two different aldehyde and reacted with NaOH, and then we get the benzyl alcohol and sodium salt. So four products are formed. First two we take benzaldehyde and formaldehyde, and two are formed like benzyl alcohol and sodium salt. Then application of the Cannizaro reaction and cross Cannizaro reaction. Benzyl alcohol is obtained by the cross Cannizaro reaction, and orthomethoxybenzyl alcohol is formed or prepared by the Cannizaro reaction. Thank you to all.